Junior. And Hal, thanks for coming. As we are seeing some rushing people just popping in right now, so maybe just give them a couple of minutes more.
Yeah, I think we can start
We
around
can start, yeah.
like 5 minutes later or so, maybe.
Yeah. Kenji, do you want to introduce yourself or
No, the senior has
Oh
proposed
yeah.
I will have
Oh,
the honor
like
to do the
she could
introduction.
introduce.
you're hosting. Oh yeah, sorry, I forgot
Yeah.
that. Yeah, no worries.
Wataru, would you like to introduce this seminar series to everyone before?
Oh yeah, for sure, yeah. So this is Asian Cultural Evolution seminar series. So we met Shinra and Kenji and me like had a just a wee chat at the Cultural Evolution Conference this year at Durham, the UK, and so we saw many culture evolution is kind of the scientific topics, has been a large topic in people in Asia as well. And but unfortunately we don't think we have kind of research or community established yet. So, and we want to have such a thing in especially like Asian time zone, because as we are all kind of struggling to participate in um, culture, society meetings and online seminars, mainly held in European or North American time zone. So we thought it'd be nice to have those such a seminar series in at least in the time zone that is easier for us to join. And yeah, so the culture evolution widely defined. So we don't want to limit ourselves to the narrow range of research method themes, but you can interpret culture evolution as wide as you imagine. So this is a kind of fast seminar series. So I can imagine, there are some people don't know this happening yet. So you can feel free to forward our previous emails or tweets or like flyer to anyone you think would be interested in this seminar. So yeah, is that enough introduction, or do you want to add anything?
Thank you so much, Wataru. And I will have the great honor to introduce you to our kickoff speaker for today. And yeah, but before that, I do want us to give a big round of applause to Kenji for making this happen. Kenji have been working very hard, like contacting people, preparing for the email, and yeah, all the like schedules. So yeah, we really appreciate that. So, Dr. Kenji Itao is currently a special postdoctoral researcher at RIKEN. He received his PhD from the University of Tokyo. His background is in statistical physics and complex systems theory. He applies these perspectives to social phenomena to study human history. And Kenji is low-key, but I just got that from website. I just know that he received the Young Scientist Award of the Physical Society of Japan this November. So big congrats to Kenji.
Thanks.
And today he's going to give us a really interesting talk on two topics, kinship and gift giving. So the title of the talk is Principles of the Evolution of Diverse Human Social Structures, Kinship and Gift Giving. So the floor is yours, Kenji.
Yeah, thanks. Thanks for a nice introduction. So I'm Kenji Itao, and I'm in RIKEN in Wataru's group. And today I'm going to talk about this. And one small thing to follow up the Wataru's introduction on this Asian Cultural Evolution seminar series, that we hold this kind of seminar series bi-monthly in the third Tuesday night, starting at this time. As I noticed that many of you join this Zoom meeting in many different time, maybe 1 hour before or 2 hours before, but this is the right time. So please come again in 2 months later for the next session. And yeah, so let me begin my talk. So my research is motivated by the structural similarity of global societies, especially observed by anthropologists and historians. For example, in many regions of the world, we have hierarchical kingdoms, maybe in present or historically. So there is a king, and there are many soldiers or elites, and the vast majority of people. This kind of social structures have been observed in like many different regions like this, and many more in for the smaller kingdoms. And for example, like not only these kind of social structures, but also the architectures like pyramids, commonly observed in this Mexico and Egypt. So my question is that why distant societies exhibit this kind of structural similarity? And we can have several hypotheses for this kind of origins of similarity. So one is that similarity comes from imitation. For example, the historical city in Japan resembles the historical Chinese city because the historically Japanese imitates Chinese culture. But what about the similarities of ancient Rome and Chinese dynasties, or like this kind of similarity between Egypt and Egypt and Mexico? That cannot be explained by imitation only. So we have another hypothesis that the similarity comes from shared ancestry. So this is because Homo sapiens originally emerged in Africa. So those cultures we shared before we exit Africa should be shared in our societies. So like the usage of fire or languages may trace back to these kind of common origins, but still, what about the post-agricultural phenomena? For example, we don't have a very big societies when we were in Africa, but do we have the shared like motivation to build pyramid-like architecture if we have like 10,000 people in this kind of societies or like that? Is like, I don't think that can happen. So I have the third hypothesis that similarity arises independently from common mechanisms. So that means the interaction mechanisms are similar across societies, but the outcomes of them vary with conditions like population size or the richness of the societies. And the similar conditions will produce similar social structures, just like water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. So I introduced the physics approach to investigate the mechanisms in social evolution. The physics approach can be explained such like the bridging micro and macroscopic levels. So what I do is to model interactions among microscopic elements and analyze the behavior of large-scale interactions of these elements. In physics, micro and macro relationships resembles or involves this kind of molecular and matter, but in social sciences, it would be the interpersonal interactions and social structures. So I do computer simulations to simulate the collective behavior of microscopic interpersonal interactions and reproduce the observed social structures by historians and anthropologists to uncover the mechanisms underlying them. So my question is, can be said like, what elements are needed to generate the observed phenomena of like social dynamics or social evolution? So my research method is starting from the leading ethnographies by the anthropologists. The anthropologists have described many detailed like reports on the societies around the world, and they have some common features. For example, in most societies, people get married and people conduct gift giving. So I built a model based on these kind of commonalities. But the like degree of marriage celebration or the frequency of gift giving vary depending on regions. So we model this kind of quantitative difference as parameters. And those societies have different social structures. For example, some societies have kings, but other societies not. So I simulate this kind of model with varying these parameters and demonstrates the variety of social structures emerge in this kind of model. And I aim to explain the diversity of social structures by parameter conditions by minimally modeling the like universal mechanisms in human history. Yeah. So to sum up my motivations, I'm interested in the universality and diversity of societies. The societies around the world are diverse, but at the same time, they show some structural patterns. And such structural patterns should emerge from the similarity in people's interactions, as long as human beings form societies. And to solve these kind of questions, I idealized anthropological observations of human behavior to simulate complex consequences of social evolutions by applying some physics approach and evolutionary perspectives to unveil micro and macroscopic relationships. Yeah, and today I will talk about two topics of my research work. One is the evolution of kinship structures in clan societies, and the other is the transition of social organizations via competitive gift giving. But before moving to these topics, if you have any questions, please feel free to ask me now, or you can ask me anytime by interrupting my talk. So yeah, feel free to ask any questions. Okay, if you don't have any questions, I will move on to the first topic. Yes. So one is the evolution of kinship structures in clan societies. So let me begin with the introduction of clan societies. The clan societies are the typical social structures in small-scale traditional societies. In such societies, there are several clans that are cultural groups of families. Of course, families are genetically related group, but the clans are just culturally related group in which people believe to share a common ancestry. But this kind of ancestries can be the sun or the moon or the heroes in the myths or like that. So they do not necessarily have genetic relationships, but because they believe to be siblings as a category or cultural category, so they do not get married within these clans. And in clan societies, there are sometimes more strict rules on marriage possibilities. For example, if you are women in clan A, you have to get married with the man in B in this case. In this case, women in A get married with men in B, and women in B get married with men in C, or like that. Here, A, B, and C are all clans, and people belong to one of them. And depending on the clan attributions, you should choose the marriage partner from only one clan, different from yourselves. Yeah. And cultural anthropologists have observed similarities at this level of kinship structures. For example, we have observed this kind of dual organizations in South American societies and Australian indigenous societies and African societies and so on. Yeah, and then my questions is that how can these kinship structures evolve? And in other words, why multiple clans evolve, but the number of clans is not only one, but not so many. So even though we have like 100 or 1,000 people, the number of clans is at most 10 or so. So there's not only one, but not so many. Then if we have like 2 to like 10 clans and as consequences of evolution, there should be some opposing forces to increase and decrease the number of clans. And I hypothesize that the marriage as microscopic relationships that explain these kind of opposing forces. In general, marriage unites the kin groups of both partners as in-laws, but at the same time, those who want to get married with same individuals will be suffered from marriage competition that often cause the mortal conflict. So, to have more cooperators, families need to have larger kin groups. This can be interpreted as a force to decrease the number of clans, to have bigger clans. But at the same time, to avoid mating competitions, families need to be differentiated by increasing the number of clans. So, my hypothesis is that these forces can explain the evolution of kinship structures, and then I built the model based on these interactions to simulate the evolution of these kind of structures. So my modeling approach is based on the commonality of tie and rivalry by marriage, and I build a model based on this. And by focusing on the quantitative differences of the necessity to have tie and the necessity to avoid rivalry, which are like expressed as parameters, and then I simulate the emergence of the variety of kinship structures in this model. So I will explain the minimal model at first, and then I introduce a bit extended model, and then finally I do some empirical data analysis to test my theoretical results. Yeah. So let me begin with the minimal model. In my model, there are several societies, and within each societies there are several families. And families interact each other, and then the number of families in the society changes over time. When the population of societies reaches some threshold, the societies will split into 2, and at the same time, another society selected at random is removed from the system. In this way, those societies composing rapidly growing families will evolve. And yeah, in this kind of multi-level evolutions operating at both family and society level, I will demonstrate the fitter societies in this system. Yeah. And as for the interactions between families, since I am interested in the marriage, so I introduced the traits and mating preferences for each family that determines families' interactions. So yeah, according to these values, the probability of marriage between men in family I and women in family J is given by this function, which means that when men's trait is close to women's preferences, they are likely to get married. And at the same time, based on these trait and preferences values, the cooperation and competition between families are determined. Those who have similar trait values recognize each other as kin, and also those who have matched T and P values are in rows, so they also cooperate. And the presence of kin and mate leads to the population growth, but at the same time, those who have similar preference values are mating rivals, so the presence of them leads to population suppression. Yeah. And children inherit further traits and preferences in this minimal model. I will extend this in the next model, but here I only consider the paternal inheritance. And initially, the values of T and P are all 0, so there is no prescribed rule in initial conditions, and these values are mutated by some noise when they are inherited. Yeah. Mathematically, the growth rate of families is determined by this way. Here, like for each pair of family I and J, I checked if they are kin because of similar T values, or in-laws, those who have the mating relationships. And according to these values, the density of friends for family I is calculated in this way. And similarly, based on the distance between family I and J's preference values, the density of rivals is calculated. As you have more friends and you have less rivals, your growth rate will be bigger. But here, there is one parameter R that denotes the relative decrease in growth rate due to marriage competition compared to the lack of cooperation. So if R equals to 0, all you have to do is to maximize cooperation. And when R is infinity, all you have to do is to reduce the number of rivals. But in the intermediate values, you have to maximize the weighted sum of these values. And finally, this marriage probability for each family I determines the mating probability. That is given by the ratio of the women who prefer the men, like one in the family I, and the density of men similar to men in family I. So these values give the relative preferredness for each family, each man in family I. Yeah. So this is all of the model, and I will move on to the simulation results. Yes. Initially, they have all identical trait and preferences values, and this shows the temporal change in the distribution of T and P values. Here, T values are plotted in blue, and P values are plotted in red. So, as with time, the distributions diverge to have 3 branches. And this is because to have less rivals, people want to diverge their preference values. But at the same time, they want to have cooperators. So they want to gather T values. And also, to have mating partners, trait values should match with someone else's preference value. So it leads to this kind of clusterization. And at the final state, we have this kind of 3 clusters in this simulation. And in this cluster, the families in these orange clusters recognize each other as kin because they have similar trait values, but their mating preferences is at -1, which is the trait values of these yellow clusters. So within these clusters, families recognize each other as kin, but they do not get married within these clusters, but they prefer families from another clusters as mate. So in this sense, these clusters can be recognized as clans in cultural anthropologies, and the kinship structures evolve as interclan relationships like this. So this simple model explains the essential mechanisms for the evolution of kinship structures. And also, by varying the R values, the relative importance of avoiding competitions rather than having cooperations, we have different kinship structures as a result of evolutions. The evolved structures depend on R values, and generally, more clans evolve for larger R values like this. So this is because when R is larger, you have to reduce the number of rivals by having more clans, because those who in the same clans have similar preference values. So the size of clans is related to the density of rivals. Yeah. So this is the essential mechanisms captured by the minimal models. And here I extend the model to consider both paternal and maternal inheritance of traits and preferences. So here we have two-dimensional traits and preferences, and they get married when these T are men's traits and women's preferences are close in terms of these vectors. And as a result of marriage, children inherit the first dimensional components of traits and preferences from father and the second dimensional components from the mother with slight noise. And mostly other parts are the same, but here we divided R to two different parameters. Here, DC determines the decrement of growth rate due to the lack of cooperation, and DM is the decrement of growth rate due to marriage competition. And their ratio is equivalent to the R in my previous model. So here, sometimes we have the similar results as in the minimal model, where only paternally inherited T1 and P1 get diverged, and in other case, only T2 and P2 get diverged, as in matrilineal societies. But in this case, both paternally and maternally inherited traits get diverged, and here these orange guys prefers these green guys as mates, and when they get married, children inherit T1 from orange and T2 from green, and then their children will belong to these A2 clans. So this can be interpreted just like after marriage, children has father's name but living in mother's village. And then by combining both name and villages, they determined their marriage partners. So in this full model, we have observed the evolution of patrilineal or double descent systems. And thanks to these extensions, we can show the evolution of all classes of kinship structures, especially the elementary structures of kinships that Levi-Strauss have described in his book. So by following the classification built by cultural anthropologists, we classify the evolved structures into these four classes: the no clans or clan endogamy, their organizations, generalized exchange, and restricted exchange. And then here I show the parameter dependencies of each kinship structures based on the necessity of cooperation and necessity to avoid mating competitions. As the M over DC gets larger, the dominant structures change from no clan structures to dual organization, generalized exchange, and to restricted exchange. So this is the mechanisms for these kind of transitions is the same as my minimal model, that the structures with more clans are favored and the larger DM over DC values. The relative importance of avoiding competition is larger than having cooperation. So as DM over DC gets larger, society shifts from this no clans to dual organization, generalized exchange, and to restricted exchange. So this is theoretical predictions of my model. If my model captures social realities, these parameter dependencies should be confirmed from empirical data. So I conducted empirical data analysis using ethnographic database called Standard Cross-Cultural Sample. And then first I identified the kinship structures in each society. And I estimated the DC and DM. First, the DC is the variables concerned with the necessity of cooperation. So I measured the degree of external warfare, which needs the massive cooperation within societies. And also, I measured the social unity, like ties across communities and social rewards for group benefit. Similarly, I measured the DM, which is the necessity to avoid marriage competitions by the disapproval of adultery, and also the degree of internal warfare, which is often resulted from the marriage competitions. And here I show the empirical phase diagram, empirical parameter dependencies of kinship structures on the necessity of cooperation and avoiding marriage competitions. So here, both diagrams are consistent in that as DM over DC gets larger, the dominant structures shift from dual organization to generalized exchange and to restricted exchange. But if I add the no-clan structures to this diagram, the consistency becomes worse. But I think this is okay because societies without clans, just like the modern Japanese societies, may have other social organizations such as governments to adapt to this kind of environment to have more cooperators and minimize rivalry. So as long as societies are organized in terms of kinship interactions, my model captures the social reality. So this empirical test somehow verifies my theoretical framework. Okay, so to conclude, I built the model based on the ethnographic findings at microscopic level of kins and in-laws cooperation and the rivalry caused by mating competitions. And then by modeling these interactions and simulating marriage relationships of families, I demonstrate the spontaneous emergence of kinship structures that are diverse between regions. And the diversity of structures are explained by the environmental conditions as consistent with social reality. So in this way, I think my theoretical framework was confirmed as the potential mechanisms for the evolution of these kind of kinship structures. Yeah, so that's it for my first part. So if you have any questions, I'm happy to answer to it.
If you have any questions, I believe you can just unmute yourself. Yes, Jinyu, please.
Hi, Kenji. Thank you for the talk. So I was wondering, I might have missed in your talk in the beginning, but do you think there's this thing called like more is diverse? Do you think if you manipulate the group size of the initial setup, it's gonna further push the diversity of the king-shape structures somehow, or like for your model, it actually doesn't matter?
Yeah, that's a good point. And it was like some kind of essential point in my latest paper on this topic. And my answer is yes. And yeah. So I didn't explain in today's talk, but we have detailed parameter dependencies of this model. So we have sometimes we have longer marriage cycle, and these figures have different marriage cycle, 1, 2, and 3. And here we have distinct cycles as in this way. And then let me indicate the results as different colors and shapes to describe the length of marriage cycle and the number of distinct cycles. And then if we change the population size and mutation rate, we get different kind of kinship structures. And in short, as this is complex. In short, the complex structures evolve if n times mu2 is large and mu2 over n is small, which means that as population size n gets larger, we have more chance to evolve more complex structures, and also such complex structures are stabilized by have larger n. So yeah, in short, depending on population size and mutation rate, we have varying types of social structures, kinship structures.
I see. Thank you. That makes sense.
I have a follow-up question to this. So I understand it's quite standard to add a mutation parameter in your model, but what do you think mutation means, like in the real situation?
Yeah. Thanks. So that's a good point. So yeah, in my model, mutation is added to T and P values. So which means that so children do not exactly follows parents' mating preferences or who your parents are. So like, yeah, and then the cultural anthropologists have observed that in some societies, the mating partners of children are determined by their parents, but in other societies, children themselves determine their marriage partners. So in the latter case, children have more chance to more chance not to follow their parents' marriage preferences or like that. So yeah, I think this kind of processes will involve this kind of mutations in cultural transmissions. Yeah, and then I don't know if it can be measured empirically, but potentially I think it's possible. Yeah.
I see, thank you. And another question, sorry, I have so many questions. So I noticed that you use the mu square instead of mu. So how did you come up with that?
Yeah, so that's not very important. So mu, where it is? Yes. Yeah. So mutation rate mu is given by the standard deviation of the noise value.
Oh,
So
I
the
see.
variance is mu2.
Okay.
But like you know, the typical size of the noise is proportional to mu values. So yeah, that's why I set the standard deviation as mu and variance as mu2. Yeah.
Thank you.
Yeah.
If you don't
You
mind,
guys-
I have sorry.
No, I was talking, so please go ahead.
No question? If you don't mind, I have one more question.
Oh yeah.
So I saw a slide where you use some, so it's the empirical part, and you mentioned some index that can represent the importance of cooperation and the importance of
Yeah.
fish. And I just would like to hear more, like what's the, like why you think this can like be used to estimate DC and DM.
Yeah. That's important and kind of difficult questions. But yeah, so first of all, we don't have any measure for the necessity of corporations that directly interpret as necessity corporation in this database. So we have to have some like related variables. So first of all, yeah, the many literature on warfare discuss the necessity of cooperation to have warfare at ethnic groups level. And yeah, there are many different variables somehow related to cooperation within societies, but yeah, so some of them are very lacking for most societies. And then, yeah, I sampled some like generally measured variables and related to this kind of cooperation somehow well. And then, yeah, so I'm not sure these 5 are the best choice to estimate this DC, but yeah, so this is kind of like, yeah, ongoing estimation.
Thank you so much.
Yeah, thanks. So if you guys don't have any more questions, I'd like to move on to the latter part of the transition of social organizations via competitive gift giving. Yeah, so this work is about the structural patterns of societies described by cultural anthropologist Edmund Service. Yeah, so he described some patterns of social organizations, including band, tribe, chiefdom, kingdoms, and states. So the band is characterized by the equal kin groups without economic or social disparities, and tribes the large unions of families with economic disparities. Chiefdom has hierarchical organizations of several classes, including chief, some elites, and vast majorities. And in kingdoms, there is a dominance of a stable, loyal family. And the states is characterized by the institutions with bureaucracy and legitimate power, yeah, and legitimately monopolizing powers, yeah. But these typologies, based on the modes of ties and production systems, or the extent of disparity, or the presence of the institutions, but the quantitative characterizations of them, or the mechanistic explanation of their transitions remain unclear. So in this work, I aim to do this. Yeah. So to explain the transition of this kind of social organizations, we have to model the change in like social relationships. And I focus on the gift as a drivers of social change. The very famous cultural anthropologist Marcel Mauss have observed the gift with 3 obligations as the universal interactions in global societies. So here, the one guy invites the other guy, and then this guy gives some gift to this guy. And the recipient should reciprocate the received gift in like 1 or 2 years or so. And then they have equal relationships. But if these guys cannot reciprocate appropriately, this guy will be subordinate to the original donor. And interestingly, in many regions, this reciprocation should be amplified like this. So yeah, in short, the gift brings goods to the recipient, but at the same time, it also brings honor to the donor. Yeah, for the ethnographic examples, they include the potlatch of the Native American societies, in which the host distributes rare goods to guests during ceremonies, and the recipients must host larger feasts, otherwise they lose their social status. And similarly, the Mocha exchange in New Guinean societies, the chiefs give pigs and shells to other chiefs, and the recipients must return the nearly double size of gifts within a few years, otherwise they are labeled as lavish men and losing the opportunity to trade fairly in the future. The last example is the Kula exchange in the Trobriand Islands, where the chiefs exchange a necklace and armbands across the islands. But here, the exchanges are of equivalent values, and act of holding these items itself confers prestige. So, as the common features, we have gift giving, and the reciprocity and status changes driven by gift givings are universal. But the interest rate for the appropriate reciprocation or the frequency of gift givings vary by context. And here, I only focus on the competitive gift giving where the interest rate exists. And I model the competitive gift giving, and by simulating them with varying these interest rate and frequencies, I show the emergence of the variety of social organizations in the model. And similar to the first part, today's my contents have four parts with like varying complexity of the model and the empirical test of the theoretical results. So this is the minimal model of competitive gift giving. Here we have the 100 individual exists, and each guy has each own wealth. At each step, individuals give their wealth as gift to randomly selected guy and produce a unit wealth of 1 and reciprocate the received gift with 1 plus R times interest. So sorry, the R times interest. So by amplifying the received gift by 1 plus R. And at this time, any shortfall results in debt, which are repaid with future productions. And by repaying debt, individuals cannot give new gifts. And to model the status change driven by gift giving, I define the weight of network edges, Qij, as a number of wealth transfers from I to J, either in the form of gift, return, or debt repayment. So if I gives J a small gift and J can return in a single step, both Qij and Qji increases by 1, which means the equal friendship. But if I gives a huge gift to J and J takes 10 steps to finish debt repayment, then Qij increases by 1, but Qji increases by 10, which means the hierarchical relationships. And the sum of Qij that directed to each guy is termed the reputation score. So the proper reciprocation ensures equality, but prolonged repayment leads to inequality. To model the ethnographic observations. So here I shows the example with R equals to 0.1, and then it shows that with time, this y-axis shows the Gini coefficient of wealth and reputation score. So the inequality in wealth increases at first, and after that, inequality in reputations increases like this. And this intermediate panel shows the relationships of Gini coefficients, and the color shows the frequency of reciprocation without having debt. So at first, they can return in a single step, but with time, Gini coefficient of wealth increases. And when economic disparities reaches some threshold, the debt frequently appears. And due to having debt, inequality in social reputation increases like this. Yeah. So this is the essential mechanisms for the development of socioeconomic disparities driven by competitive gift giving. And also, we can show the evolution of network structures like this. And here, only edges with the weight larger than some threshold are shown. But as with time, the network becomes denser. And so like first, the network is sparse, but we have denser network in this case, and the network is hierarchically organized that are mostly directed to a few rich individuals. So this kind of hierarchy can resemble the social structures of chiefdoms, and this large union may represent tribes, but initially we don't have any kinship interactions, so it's far from band societies. So to describe the transitions in social organizations, I introduced the generation alternation minimally in the next model. And in the final full model, I described the kinship interactions in detail. Yeah, so in this second model, I introduced the frequency of gift giving, L. So with probability of 1 over L, individuals die and are replaced by new ones with initial conditions. So typically, individuals live for L steps. So this L can be recognized as the typical number of gifts one experiences within their lifetime, or this can be recognized as average lifespan. But anyway, we have these L parameters in the model. And to normalize the value of wealth and scores, so I made that the wealth is produced at the rate of 1 over L in each steps, and the reputation score is given by the sum of Q directed to oneself over L. But this is not very important, but the most important thing is that individuals die within a finite lifespan. So thanks to this extension, the distribution of wealth and reputation score within societies leads to the steady distributions, depending on parameters of the interest rate R and the frequency of gift giving L. And here I show the log plot of wealth and reputation score and the log plot in this small inset. Yeah. And I fit distributions with either exponential distribution or power law distribution, which are linear in log plot or the log plot. And overall, the wealth distribution shift from exponential to power law with smaller R and L values. And reputation score are exponential at first, but then when R and L gets sufficiently larger, they shift to power law. But then if you make R and L values extremely large, they revert to exponential distribution. But this time, they have some exceptionally rich individuals, which I term monarch. Here, and I want to explain why I'm like stick to explain the change in distribution shapes between exponential and power law distributions. This is because in statistical physics perspectives, the distribution shapes are related to the mechanisms underlying them. Here, I want to briefly explain the coin exchange game, where the one of three individuals give a coin to randomly selected one of the other two in each step. So what happens in this game can be represented as the random walk in this diagram A. So if this last guy is selected as a donor and this first guy is selected as recipient, the system moves to this point, and this kind of 2, 1, 0 distribution is realized. And interestingly, the equal distributions where each player has one coin is the most unlikely to be observed. And if you do this kind of simulations, almost all time you get this kind of 2, 1, 0 distributions. And this trend become much more clearer as you increase the number of players n. And we can mathematically show that the most likely distributions follows an exponential distribution. So what I want to say is that the exponential distributions represent natural disparity caused by random exchange, but if there is power law distributions, there should be some unnatural mechanism driving them. So some special mechanisms underlie power law distributions. So it is very important to distinguish distribution shapes to detect underlying mechanisms. And yeah, in nowadays society, most of populations, the wealth distributions of most populations follow the exponential distributions, but some of super rich guys follow power law distribution. Like in US, like Bill Gates or Elon Musk follow this kind of power law distributions. But yeah, in statistical physics perspectives, we can detect several special mechanisms, kind of richer process underlying these kind of phenomena. Yeah. So similarly, these exponential distributions should be explained by the random exchange of gift giving, but this kind of power law distributions should be driven by some special mechanisms to extend the degree of socioeconomic disparities. Yeah, so to mathematically characterize the distribution shape, we measure the coefficient of variation, which is given by the standard deviation over mean. If distribution is exponential, this CV value equals to 1, but if it follows power law, it gets larger values. And these different lines shows the different RL values, but here x-axis shows the multiplied RL values. So yeah, like in this point, we have a different set of R and L, but they are, yeah. So RL is equal in this point. Yeah. And then as you can see, the systems, the results of the system depend only on RL values. And at some certain point, the wealth distribution shift from exponential to power law, and similar shift in repetition score happens with larger RL values than wealth. So here we can get the phase diagram based on R and L parameters and of the bands shown in purple without economic or social disparities, and yellow is tribe where only economic disparity exists. And in this green chiefdoms, both economic and social disparities exist. And in this gray, only economic disparity exists, and the social disparity between vast majority of population is diminished by the suppression by exceptionally rich monarchs. Yeah, I will characterize them in social network structures in the final model, but before that, I want to briefly explain that this kind of phase transitions can be calculated analytically. Yeah, I don't want to detail this kind of equation solving, but yeah. So in the wealth dynamics in my model can be explained like this. So in each step, they earn 1 over L wealth, and by giving their wealth as gift, they get R times WI as interest. But by receiving gift from other guys, you have to pay interest like this. But here we have random variables that represents that people randomly choose the recipients of the gift giving. So we have some steady growth term and exponential growth term due to the receiving interest for your gift, but some fluctuations based on receiving gift. And mathematically, if we ignore this exponential term, we can get exponential distribution. But if we ignore this fluctuation term, we can get power law distributions. And the conditions in which this fluctuation or exponential growth can be ignored is calculated with simple assumption. And then this provides the conditions of RL values where the phase transitions between band to tribes occurs, or like that. Similarly, we can explain the phase transitions in the distribution shapes of reputation score can be calculated. So if you want to know the detail on this kind of calculation, please ask me questions in the latter part. But now I want to introduce the full model to explain the development of social networks through competitive gift giving, the model 3. Yeah. So here, each guy has lifespan L following Poisson distributions with mean L, and the number of children follows the Poisson distribution of like this. So which means that unlike model 2, each individual can have multiple offsprings who inherit the parents' wealth and network connectivity, and also the number of children increase with wealth. And most importantly, siblings are connected with some edge weights, so due to kinship relations. Yeah, so as a result, depending on L values, the network structures shift from this kind of small clusters connected sparsely to this kind of large union of societies and this kind of hierarchical network structures in which the allos are concentrated on a few super rich individuals. And also the phase transitions in steady state distribution shapes of wealth and score replicate model 2. So this is the tiny extension on network structures due to kinship interactions. And we get similar phase diagram for this. So yeah, to conclude, what we found in theoretical models is that I model the gift-giving relationships where equality is maintained when gifts are reciprocated with R times interest. Otherwise, hierarchical relationships form. And also, the kinship ensures persistent connections. Here, when RL is small, the kinship clusters dominate, forming egalitarian bands without economic or social disparities. And when RL is intermediate values, inequality emerges due to interest with R, and network structures form large unions, such like tribes. And when RL is large, the wealth disparities and debt lead to hierarchical chiefdoms. And finally, when RL is extremely large, extremely wealthy monarchs emerge, and then these guys suppress other guys' economic activities, and social disparity of vast majority is diminished. And like in kingdoms, the stable loyal families evolve in this case. So what I found is that social organization types can be characterized as discrete classes, at least for the distribution shapes of socioeconomic disparities. And here I propose the interest rate R and the frequency of gift L as explanatory variables for social organizations. So I test this by empirical data analysis of the same ethnographic database. So here I estimate the degree of gift. I couldn't distinguish the frequency and the interest rate, but this compensation demands is known as the one of common starter of gift giving. If one group, one guy in one group killed another group's guy, then those in the second group can demand some compensation gift from the original group, like that. And in anthropology, taxation or tribute are recognized as one kind of gift. And also, more directly, the degree of marriage celebrations or the size of gift exchanged in marriage celebrations are measured. So I analyze these values to estimate the gift degree. And also, I analyze estimated economic disparity and social disparity by using these parameters, in the database. So here I show the gift degree and disparity. So each point shows each society, and blue dot shows the economic disparity, and orange dot shows the social disparity. And in this right-hand figure shows the average value of disparities for tiny beans like this. So it states that as gift giving is more frequent and more extensive, economic disparity arises first, and then social disparities arises secondly, as consistent with my model. And finally, the correlation between the gift degree and other variables in this database is shown here. So by combining this analysis with my theoretical results, we can say that the population density and surplus productivity increases the gift degree, and it leads to the social hierarchy and the social complexity. So as for the historical perspectives, we can say that surplus production from pastoralism and agricultures or increased population densities fosters the transitions in social organizations through increased gift giving. So unlike previous scenario that the hierarchical differentiation is due to surplus production sustained non-producers. But my theory is that hierarchical differentiation is because surplus production acts as a catalyst for interactions to develop hierarchy. So although this study argues that as the degree of gift giving increases, societies shift from bands to tribes, chiefdoms, and kingdoms, but I don't claim that history should progress in this way unidirectionally. This is because that if population size reduces or the environment changes, the gift giving can be reduced and it can reverse direction. So what I say is that the parameter dependencies of these social organizations are unidirectional to the value of RL values, but the historical paths can be fluctuated on the phase diagram on R and L. So I integrate the gift theory on microscopic interpersonal relationships and the theory on macroscopic social organization structures. And I explain the historical mechanisms that are universally applicable to any human societies. So that's it for my second part. So thank you for your attention.
Kenji, can I ask one question?
Yeah, of course.
Yeah, about your this second part of your talk. So in this model, so this is amazing that this simple assumption still generate the pattern fits very well with the actual human data. But I wonder, it's like if kind of forgiveness might play a role or might change the kind of dynamics, like forgiveness in terms of
Mm.
like if your partner didn't return the money back to you. This is like it's also well known in simple tit for tat strategy, right? So tit for tat, the basic tit for tat strategy wouldn't forgive those uncooperated, and then this makes the reciprocal relationship to kind of deadlock if there's some chance to, like, by any, sometimes your partner are not very well and not be able to return the reciprocal way, and then tit for tat strategy just continue to defect, and then the society just got stuck in a. But if it could still do some forgiveness strategy, then the society can also return it back to the more cooperative state. So do you think, like, do you have any thoughts on that?
Yeah, that's a good point, I think. And so in some sense, my current model can be recognized as the worst case for the development of disparities. And like in ethnographic reports, it is so these examples are basically on the competition of social status between chiefs, or like the great men or big men in anthropological term. But in other cases, or for example in like daily treatment, they give food for poor guys without expecting any reciprocation, or like in many cases interest rate can be negative. Like, so you have to reciprocate, but if you return only a half what you get, it is okay, or like that. So if that kind of like a cooperative behavior exists, it is unlikely to have these bigger disparities. But my point is that still, even though in that case, of course, economic disparity is not generated as it is modeled in this case, but the emergence of social disparities, or like in the sense of that, by embedding economic disparity to social disparities, can be facilitated by these mechanisms without positive interest rate. So yeah, if we like describe many more nuanced case of such forgiveness, or like generosity, then some parts of my mechanisms is rejected, but other parts should be held
I
in
see.
that case.
Yeah, I see. Yeah, so that makes sense. It's actually, so thanks to the assumption here that the behavior is more kind of continuous rather than like corporate or defect.
Yeah.
So then each individual can tune the kind of amount of cooperativeness or like gift. So that's great. Yeah, thanks.
Yeah, maybe. So, for example, it's possible in social reality that if you give a gift to near friends, you don't need any interest. But in other case, you set very high interest to compete your status. Then, like that kind of nuanced choice between cooperation and defections can be modeled in the future, and it would be, I think it's necessary to show the evolution of interest rate in this model, because this kind of interest values is agreed within society, but it's not self-determined by environment. So to discuss such cases, your point is very important, I think.
Right.
Yeah.
Thank you.
Thanks.
Hi, Kenji. I have another question relating to the emerging network structure part where you showed the parameter of L, the gift frequency.
Yes.
Yeah, somewhere over here. No, some slides later.
Later.
Yeah, a little bit
I think this is
later.
final one.
Or previous
Network
one?
structure. This one?
Yeah, this one.
Oh,
Yeah, either this one or that one later. I'm wondering, have you checked the degree distribution of the structure, like this kind of transition thing? Because I was wondering, for example, at the time, like 1,000, like when it's like evolved like couple of trials, do you think this kind of structure is more like scale-free distribution, like this kind of like power law, or is more log normal? I wonder.
yeah,
'Cause
yeah,
this
yeah.
argument where they argue, like because usually they assume that it just is scale-free like power law distribution, right? For the
Yeah,
like
yeah,
it's
yeah.
kind of like extreme degree heterogeneity, right? But then I remember there's this article coming out arguing that actually they tested this with the real world like data and found out it turned out log normal distribution actually fits better in general.
Yeah, yeah, yeah.
So scale-free is actually kind of rare. So I was wondering, for example, from 100 to 1,000, the third one, the fourth one, do you expect the transition was going to be, or is there even any transition between this log normal and the power law distribution?
Thanks. That's
Yeah, I was wondering what
And
which eventually would emerge, or
yeah,
it just
yeah,
like
yeah. So first of all, in short,
Mhm.
the reputation score is the
Mhm.
network degree in my
Mhm.
model. So like having so I should examine this sorry, this can better be fitted by power law or log normal. But as I was interested in the transition between exponential and power law, so I didn't detailed the distinction of them. But mathematically, we can get something like power law distribution with like some like movement in axis, but still I think it's within the class of power law. So I think the power law distributions evolve in this case. So yeah, if
But that's the wealth,
like
right? That's not necessarily the degree.
yeah, that yes,
That's something
yes,
different. I
yes,
think.
yes, 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 and in the net, sorry, this degree for these degree distributions, the power law emerges somehow by embedding the power law nature of wealth distribution to this kind of reputation score. So yeah, uh, I think it generally follows power law, and my point is that if we want to detail the difference between the power law and log normal in social reality, that this may be some evidence that I ignore some important aspects of social reality that shift this power law distribution to log normal, but I don't have a clear idea on it. Yeah.
I see. Yeah, thanks.
Yeah,
Thanks.
I guess that there's a positive correlations between like network degree and this individual's wealth, I guess. So that's therefore
Yeah, that's also under.
Yeah,
therefore, yeah.
that's kind of not that simple, but like if the both follows exponential distribution. So here I showed the correlation between the wealth and reputation score, network degree. But at first, if you receive many gifts from many individuals, you just become poor. But having relationship with many guys, your reputation score increases. So at first, without any economic nor social disparities, there are negative correlation between wealth and reputation. But the negative correlation, still the correlation size is very small. But if once there is social disparities, the having debt leads to the having more wealth and having more larger reputation score, then the correlation becomes this kind of significant values. So yeah, so what can be said is that if we can measure the correlation of wealth and reputation in reality or empirical data, then it should be also serve as some measure for this kind of social organizations or the extent of disparities. Yeah. Okay. Is there any other comment or questions? And
Then can
if
I
not-
ask about
Oh, yeah,
another?
yeah, of course, of
It's
course.
just a minor point.
Yeah.
Perhaps. So in the it's again the second model of a second part of your
Okay.
talk.
Yeah.
In the phase diagram you showed about like L and R. Yeah, I guess that's it. So L. So I remember correctly. L is expected longevity time, right? So if
Yes.
so, which means like L10, like is like power 3 or 4. So
Yeah,
these
yeah.
parameter region seems to be kind of super. So it needs to be really super long longevity is required. So does it mean like it's actually unrealistic, or it's just a matter of scale? But still, the scales from like 10 to like 10, like 1,000 is quite like a large gap.
Yeah.
Yeah.
So thanks. So first of all, this L shows the average lifespans in terms of the number of events of gift giving. So if you only make gift in the marriage celebrations of your siblings, then L should be at most 10 or like 5 or so. But if you are kings and many guys come to you to exchange any goods in daily basis, it can be like 10 to 4 or like 10 to 5, because these counts each individual gift giving as one step. So if you exchange gifts with 10 people in a single day, it should be counted as 10. So like
I see.
it doesn't show the 10 to 4 years or so. And another interpretation is that in this case, people die and then they are switched to like the new individuals with initial conditions. But in like medieval European history, there was a significant emergence of like family inherit the merchant family, in which they inherited their wealth and network connections to their children. So in that case, although a single guy dies within a limited lifespan, but his or her families can last much longer than a single guy's longevity. So yeah, I think these parameters will explain something.
I see, gotcha. And then so in this current scale you show, there's a tiny space only being black, like gray, like a kingdom.
Yeah.
But if you like extend this both x and y axis to like farther, then you kind of again see the kind of largely negative slope of like a band of gray area, I guess.
Yeah, it should be. So this slope is due to having this. If R times L is equal, mathematically the identical mechanisms are operating in those cases. So, like here, we should observe gray kingdom,
Mhm.
or like here.
I see. Thanks.
Thanks. So if you guys don't have any more questions, I want to quickly summarize my talk, and then I briefly explain some of my other topics. So one is the evolution of family systems and resultant socioeconomic structures. So in modern societies, the family systems are diverse between regions. And in some societies, like in Japan, the families live with their grandparents, and only one heir inherit the family wealth. But in other societies, like in China, in this case, they live with their grandparents, but they equally inherit the inheritance between siblings. But in other regions, like in Europe, they have nuclear family in which the children get out of their parental home when they get married. Yeah, and then the demographers have observed the correlation between the types of family systems and the social ideologies in modern societies, but they don't explain the mechanisms behind the correlations. So I built a simple model to discuss the evolution of the time in which children leave the parental home and the rules of distributions of inheritance between siblings. And I show that the family systems depend on the land capacity and the wealth required for survival. And additionally, depending on the family systems that evolved, the wealth distribution shape in societies are determined. And by expecting that when there is more poor people, the also authoritarian policy is more likely to support it. And when they are more rich people, egalitarian policy is more likely to be rejected. We explain the correlation between the environment, family systems, wealth distribution, and social ideology. And I also have some work on the modern fertility decline, which I term two universal pathways in demographic transitions. Like in modern change in longevity and fertility, there are two different trends in their change. And on these two master curves, each individual country's pathways are aligned. So yeah, if you are interested in these works, feel free to contact me, or please find these papers for more information. Yeah, so to sum up, I'm working for constructing a novel theoretical research field called universal anthropologies. And I'm interested in the mechanisms underlying social structures that can operate throughout human history. For now, I have analyzed the mechanisms depending on the societal scale and wealth. So one is the kinship structures that emerge from marriage interactions, and another is the gift givings driving transitions in social organizations. And when the inheritable wealth is accumulated, the family systems are diverged and that are correlated to modern social ideology. And in modern societies, mortality declines first, followed by fertility, but their pace of change in fertility has two different phases driven by different mechanisms. And yeah, for all of these projects, what I do is to model common human interactions in various societies and to simulate the emergence of social structures conditioned by the quantitative difference between societies. And I'm aim to propose universal mechanisms and measurable parameters to elucidate the theory of human history. So if you are interested in, so feel free to contact me in the future, or like, yeah, I'm happy to discuss with you in any community. Yeah, so thanks for your attention.
Thank you, Kenji, for the wonderful talk. And thank you all for joining us today. So our next seminar will be the coming January 21st. That will be delivered by Dr. Kevin Hong from the University of Macau. And he's going to tell us something about game of chance. And we look forward to seeing you all. And thank you, everyone.